In 2023, artificial intelligence data centers quietly consumed 4% of all U.S. electricity. By next year, that number will double, fueling a surge that has never been seen on the American grid. Training a single artificial intelligence model now draws as much power as 1,000 homes. One campus can demand electricity for 800,000 households every minute of every day. Utilities missed the warning signs using outdated models, while nationwide demand spiked 20% in just 2 years. Why did the experts get it so wrong? And what happens when the most important system in America buckles under the weight of artificial intelligence? The answers begin with the relentless roar of machines that never sleep. The AI appetite for electricity now rivals entire nations. In 2023, data centers running artificial intelligence consumed 4% of all United States electricity, more than the combined output of several major power plants. By 2025, projections show that share will double to nearly 8%. That is not a gradual uptick, it is an explosion, especially for a grid that spent 2 decades barely growing at all. For years, national electricity demand hovered in place, held steady by efficiency gains and the offshoring of heavy industry. Then in just 24 months, demand spiked by 20%. That single leap added the equivalent of powering 25 million American homes, almost overnight. The scale is difficult to grasp until you break it down. A single large AI data center now draws a continuous load of 500 to 1,000 megawatts, matching the power needs of a mid-sized city every hour of the day, every day of the year. Unlike homes or even factories, these facilities never rest. Their servers run at full tilt around the clock, creating a constant, unyielding demand that utilities struggle to keep up with. It is not just the size of these facilities, but the intensity of the work they do. Training one advanced AI model, like GPT-4, consumes as much electricity as 1,000 American homes use in a year. Even the simplest AI tasks add up. A single ChatGPT query now uses 10 times the energy of a Google search. Multiply that by billions of queries, and the impact becomes staggering. The numbers keep climbing. Goldman Sachs predicts that by 2030, data center power demand in the United States will rise another 160%. That would push AI share of the grid to levels no one planned for, outpacing the growth of every other sector combined. What was once a background hum of servers has become a relentless surge, straining a system built for a different era. The grid is no longer just lighting homes and running factories. It is powering the engines of artificial intelligence at a scale the country has never seen. Rows of black server racks stretch the length of a football field, each one packed with thousands of specialized chips. These machines are not just humming, they roar, cooled by industrial fans and liquid systems that would belong in a power plant. Inside, the hardware is built for a single purpose: to feed AI models with endless streams of data at speeds and volumes that defy comparison to anything in the digital past. A single AI server rack can draw between 40 and 100 kilowatts, enough to power a small grocery store or dozens of homes from a space the size of a closet. Multiply that by hundreds or even thousands of racks, and the numbers begin to dwarf entire neighborhoods. The most advanced facilities, like those training models on the scale of GPT-4, pull so much power that the yearly electricity for one training run matches what 1,000 American households use in a year. That is not a typo. One model, 1 year, 1,000 homes. But these buildings are not like old-school data centers where traffic ebbs and flows with the business day. AI workloads never sleep. The chips inside are designed to run at full throttle, 24 hours a day, 7 days a week, pushing electrons through silicon with relentless force. The result is a constant, unblinking demand on the grid, No peaks, no valleys, just a steady surge. Engineers who manage these sites compare them to factories that never shut down, except the product is raw computation, and the fuel is electricity. The scale is almost surreal. A single hyperscale AI campus can consume 500 to 1,000 megawatts, equivalent to the power needs of a mid-sized city. Microsoft's new AI complex in Iowa, for example, is expected to draw as much electricity as 800,000 homes. That is more than many entire states. Each campus is a self-contained energy ecosystem, often with its own substations, cooling towers, and backup generators, all built to keep the servers running no matter what happens outside. Behind the glass and steel, anonymous engineers monitor dashboards lit up with real-time power metrics. Their job is to keep every chip fed, every rack cooled, every watt accounted for. They know that even a momentary interruption could cost millions, or worse, derail days of AI training. In this world, uptime is not just a goal, it is a mandate, enforced by layers of redundant systems and a constant stream of electricity. The physical reality of AI is not just code and algorithms. It is a hardware arms race measured in megawatts and engineered for a future no one fully anticipated. For decades, utility planners trusted the same basic playbook. Their models, built on 50 years of history, assumed that America's appetite for electricity would grow by just 1 or 2% a year. Efficiency gains and an industrial slowdown after 2000 had kept the grid stable, and the Department of Energy's official forecasts reflected that calm. In January 2020, the Department of Energy's annual energy outlook predicted only a modest rise in demand through 2025, about 1% a year at most. Data centers were treated as a small slice of the commercial sector, their projected growth barely registering against expected savings from LED lighting and smarter appliances. But reality took a different path. As AI exploded, electricity demand outpaced every projection. The Department of Energy's 2020 models saw data centers using about 100 terawatt hours by 2025. Actual usage is now on track to hit more than double that, well over 200 terawatt hours, eating up as much as 8% of all United States electricity by next year. In raw terms, the Department of Energy missed the mark by at least 150 terawatt hours, enough to power every home in Texas for a year. That is not a rounding error. It is a gulf so wide, it has forced utilities and regulators into a scramble just to keep the lights on. The root of the problem lies in the assumptions. The models expected industrial decline to continue and for new technology to keep making everything more efficient. But AI workloads did not follow the old rules. Instead of peaking during business hours and dropping off at night, AI data centers drew power around the clock at constant levels, far beyond anything the grid had handled before. The models had no way to account for thousands of racks each, pulling 40 to 100 kilowatts, or for hyperscale campuses demanding as much electricity as entire cities. By 2024, the gap between forecast and reality had widened into a full-blown crisis. Department of Energy analysts, once confident in their 1% template, now faced a world where annual growth topped 5% and showed no sign of slowing. Regional transmission organizations, relying on the same legacy math, found themselves blindsided by the scale and speed of the AI surge. The numbers were in black and white. What the models missed, the grid now had to deliver. In Loudoun County, Virginia, the grid faces a test it was never designed to handle. Here, a cluster of data centers now draws 2,500 megawatts, more electricity than the entire city of San Francisco. Local officials sit in meetings with charts showing power use that dwarfs every other sector. 70% of the world's internet traffic passes through this county, but the price of that status is clear. Substations are maxed out. Transmission lines are at capacity, and every new data center application triggers a debate about whether the grid can take any more. Dominion Energy, the main utility, has filed emergency petitions with state regulators, asking for permission to delay or even deny new data center connections because the infrastructure simply cannot keep up. The bottleneck is not just in the wires. Equipment like extra high voltage transformers and new substations comes with a wait time of 3 to 5 years. Even when funding is available, global supply chains are backed up. Contractors warn county boards that some upgrades will not arrive until after the next presidential election. Meanwhile, tech companies are offering to pay hundreds of millions for priority access, hoping to jump the queue and secure enough power to keep their AI projects running. But money cannot buy time when the equipment does not exist. Across the country in Morrow County, Oregon, the numbers tell a different kind of story. Here, data centers outpace residents in power use by a ratio of 100 to 1. The county's population hovers near 12,000, but the electricity drawn by the server farms could supply a city 100 times that size. Local officials review permit applications that would double the county's total power demand in a single year. The water district raises alarms about cooling needs, billions of gallons at stake for the next round of AI upgrades. Utilities file their own emergency requests asking for relief or the ability to slow down new hookups until the grid can catch up. In both Loudoun and Morrow, the strain is no longer theoretical. County planners, utility managers, and local boards face choices that pit economic growth against basic reliability. The numbers on the charts are not just statistics, they are warnings, and the lead times for relief stretch far beyond the urgency of the demand. Microsoft's new AI campus in Iowa is set to draw as much electricity as 800,000 homes. That is not a hypothetical figure. Utility filings and state records show the company reserving a full gigawatt of capacity, enough to power a city the size of San Francisco, all for a single corporate campus. The electricity will not just feed office lights and laptops. It is earmarked for racks of high-density servers, running AI computations around the clock, every day of the year. In a state where data centers already claim more than 10% of the total grid, this one project stands out for its sheer scale and exclusivity. Local officials describe the deal as a private arrangement, one that effectively walls off a chunk of Iowa's power supply from everyone else. Microsoft is not the only tech giant redrawing the lines of who gets access to the grid. In Pennsylvania, Amazon negotiated a deal for nearly the entire output of the Susquehanna nuclear plant, a partnership valued at over $500 million. This is not a traditional power purchase agreement. Amazon's arrangement with Talon Energy ensures dedicated nuclear generation for its data centers, bypassing the open market and locking in a supply that once served thousands of homes and businesses. The plant's output, 960 megawatts, now flows directly to Amazon's servers, fueling AI operations that never sleep. For the surrounding community, the shift is unmistakable. What used to be a public resource has become a private engine for cloud computing, with local ratepayers left to absorb the ripple effects. The pursuit of exclusive energy does not stop with contracts. Microsoft has partnered with Constellation Energy to restart 3 Mile Island Unit 1, a nuclear reactor shuttered since 2019. The entire output, 835 megawatts, will be reserved for Microsoft's AI infrastructure, pending regulatory approval. Constellation's filings with the Nuclear Regulatory Commission outline a 20-year commitment, with Microsoft underwriting the costs of bringing the reactor back online. If approved, this will be the first nuclear plant in the U.S. revived specifically for a single corporate customer. The deal bypasses the grid's traditional priorities, channeling carbon-free power straight into AI data centers, while leaving residential and industrial users to compete for what remains. These arrangements are not isolated experiments. They signal a new era in which tech giants carve out private slices of the nation's energy supply, using their financial muscle to secure priority access. The consequences ripple outward. As more power is locked away for AI, the rest of the grid faces rising costs, tighter supply, and growing uncertainty about who gets electricity and at what price. Electricity bills are climbing at a rate not seen in decades. In 2024, the average household faced an 18% increase, erasing years of efficiency gains and forcing families to rethink their budgets. Utilities point to the same culprits: AI data centers driving relentless demand, record investments in the grid, and the race to keep up with technology that never pauses. The outlook for 2025 is even more severe, with bills projected to rise by another 25%. For millions, these numbers are no longer theoretical. They show up every month, reshaping daily life. Grid planners see the strain in real time. PJM interconnection, responsible for keeping the lights on for 65 million people from Chicago to Washington, D.C., warns of a looming shortfall of 6.6 gigawatts by 2028. That is enough to threaten reliability across the entire region. Recent auctions failed to secure the capacity needed as demand from data centers surges. Internal projections show the gap could widen to 14 gigawatts by 2030, with AI and cloud computing at the center of the storm. These figures are not just forecasts, they are the dividing line between stability and rolling blackouts. Financial analysts echo the urgency. Goldman Sachs predicts U.S. data center power demand will jump 160% by the end of the decade. Meeting that growth means more than $100 billion in new transmission lines, substations, and backup generation, costs already trickling down to consumers. Fixed charges are rising, and peak pricing is spreading to areas that never worried about summer outages. Consumer advocates call it a historic shift of costs from households to big tech, as the grid bends to serve new masters. The environmental toll is mounting too. Each advanced AI training run can use 700,000 liters of fresh water, enough to fill an Olympic pool just to keep servers cool. Multiply that by thousands, and entire counties now ration water between farms and server halls. Emissions, once falling, are rising again as utilities turn to coal and gas to meet the unyielding load. Every promise of a cleaner grid is now weighed against the demands of AI. At every level, the same questions press in: who pays, who gets priority, and how much risk is tolerable. Policy options are few and fraught. Some states consider halting new data center hookups. Others debate special tariffs or cost-sharing rules. Grid operators plead for federal help to modernize before the next crisis. The reckoning is here, and the choices made now will echo for decades. Today, every new AI breakthrough demands more power than our grid can safely provide. As utilities scramble and bills climb, the question shifts: who decides how much is enough, and who pays the price? This is no longer a distant warning. The cost of digital progress now arrives at your doorstep, measured in dollars, carbon, and choices we cannot afford to ignore. What do you think? Where should the line be drawn?